average rates of change. So first of all, we're going to look at examples of increasing, decreasing, and constant functions. So what you need to know here is that if a function is increasing, the graph is going to be going up. That's what you need to know. Okay, that's what an increasing function means. It goes up. A decreasing function, on the other hand, means that the graph does what? It goes down. That's what a decreasing function means. It goes down. It decreases. Okay, so that's what they mean. Don't get all bogged down in this terminology. Increasing means the graph goes up. It increases. Decreasing means the graph goes down. Constant means that the graph does what? Stays the same. And so really on this graph, we only have a constant area right there. So a graph is constant if it's horizontal, if it doesn't move up or down any. Okay. So that's the three things you need to remember. Increasing goes up, decreasing goes down, constant stays the same. So with that in mind, we're going to go ahead and look at this example. It says use the graph of each function to estimate intervals to the nearest half unit on which the function is increasing, decreasing, or constant. Don't worry about this spot right here. Okay? So on your homework, what you're going to be given is you're going to be given graphs just like this. And what we're going to have to do is determine where is the graph increasing or decreasing. So if I start up here at the leftmost point, what am I doing? Decreasing, right? What am I still doing? Do I ever switch? What do I do the entire period? Decrease. So this is what you'll write. You'll write decreasing, and so you can abbreviate DEC if you want. And if I want to write the whole graph, I'm going to start at negative infinity, and I'm going to go to positive infinity. And that's it. That means all the numbers from negative infinity to positive infinity.
What's the DEC example?
Decreasing. Okay?
So it's the negative infinity, positive infinity going left to right now.
It always goes with your x values. It never goes with your vertical values. Okay? Always your x, never your y. So let's look at another one. So let's look at this one.
Are we not bothering with the f of x?
What do you mean? Did I skip one? No, you're good. That's it. That's all you need to do. Okay? So let's look at this one. So now what we're going to do, okay, is I'm going to start at the leftmost point. So I'm going to start at the leftmost point, and I'm going to figure out, okay, what am I doing as I move along this graph? I'm increasing. So this is where we start. So I can write increasing. My starting point will be negative infinity. Okay. Now I need to figure out at what x value do I stop increasing. So let's see, am I still increasing? Still increasing? Still. Right here. So this is my stopping point, right? What x value is that?
2.
What x value is that?
Negative 2.
Negative 1. Okay? So now, at this negative 1 value, what do I start to do?
Decrease.
I decrease. So I start decreasing at negative 1. At what point do I stop decreasing, or do I even stop decreasing?
Positive.
At positive 1, right here I stop. So I'm going to put positive 1. At positive 1, what do I do? I start to increase, so I'm going to come over here and put a comma, positive 1. At what value do I stop increasing? Positive infinity. And there you go. Questions?
So we absolutely don't need to worry about the...
Nope.
So when you do the numbers, like it's on the x, not the
Always on the x. Okay? Always on the x. All right, so we've got 2 more we're going to look at, and then we'll probably call it good for today. So we're going to walk through the exact same steps that we just did. So I start at the leftmost point. What do I start doing at the leftmost point? Decreasing. So I write decreasing. I start at negative infinity. At what point, if any, do I stop decreasing? At 2. Good job. So right here is where I stop decreasing. And then what do I start doing? Increase. So I'm going to write increase, and I start increasing at 2. At what point do I stop increasing? Infinity. Good job. Okay. So are we so far so good? Okay, what do I start doing on the bottom graph? Increasing. At what point do I cease to increase?
1.7? No, wait.
Okay, so about like negative 3 point something. So we could do negative 3.2. Because if you remember what it said about within 0.5 of a unit. So within half a unit. So negative 3.2. What do I start doing at negative 3.2? Constant. So negative 3.2, when does it stop being constant? Infinity. Okay. So we're going to go ahead, and I think that's probably my last example. Right. And so what we're going to do is eventually tomorrow we're going to talk about extrema. Now extrema are basically high points and low points. And so we're going to evaluate the graph for high points and low points. And so if you want to go ahead and get started on your assignment, this is what you can do. Okay? And then we'll talk about the average rate of change. On pages 40 through 41, 2 through 26 the evens, 34 through 40 the evens, and 48. What you can actually do based on what we just did in class is 2 through 10. So 2 through 10 is what we just got done doing in class.